2020, question 9. Two ships set sail at the same time. Ship A from port A and ship B from port B. Port A is 90 kilometers. We have this 90 due west of B. Ship A is traveling due east at 15 kilometers an hour, and ship B is traveling due south at 30 kilometers an hour. Find the distance between the two ships 30 minutes after they set sail. Well, 30 minutes after they set sail, A is going to be closer to where B was, and B is going to be going south in this direction. So this was 90. What is it now? A is going at 15 kilometers an hour. So in 30 minutes, A has gone 7.5. So this is now 82.5. B is going at 30 kilometers an hour and half an hour, 15 km. So this is 15 km. So the distance between them, here's A, here's B. It is a Pythagoras question. Can you believe it? I believe it's our higher level. 82.5 squared plus 15 squared, which is equal to 83.8525. 83.85, 2 decimals, 85 kilometers. T is the time in hours after they set sail. Show that the distance between the ships, well, this is the distance here, this x here is the distance between the ships, at time t can be given by the function. Okay, so we're given this function, so it's the square root of something, which is clearly the square root of this guy, just in terms of t. So what's happening? Let's do another diagram. What's happening along this line? A starts here, it was 90. After 1 hour, it's going to be 90 minus, what speed is A going at? 15. 90 minus 15t. So in 1 hour, he's going to be 15 closer, in 2 hours, 30 closer. And B is just going in this direction at 30 kilometers an hour. So he's just going to be in 1 hour 30 and 2 hours 60. So we just changed the sides of our triangle here. And this hopefully works out to be what we have above. We can see we're going to square them. So we're definitely going to have the 8100. So this, we're on the right track here. So we know that x is equal to the square root, or we're going to just put it to the power of a half. So x is equal to 90 minus 15t to be squared plus 30t to be squared, all to the power of a half. So I multiply out the first bracket. 90 squared is 8100. 90 by 15t twice, well that's 1300 twice, minus 2700t, and 15 by itself is 225t squared. That's the first bracket. Second is just 900t squared, and that's all to the power of a half. So we're going to get t squared, we're going to have 900, we're going to have to add 125, that's 1125 t squared minus 2700t plus 8100, all to the power of a half. So we have shown what they've asked us to show, quadrat demonstrandum. And this is only a 25 mark question to end the leaving cert. Very unusual to have a long question. It hasn't happened since 2010 that a long question is only 25 marks, but use calculus to find the value of t when the ships are closest to each other, and find the distance between the ships at your value of t, and give distance in kilometers correct to 1 dp. So we want the minimum distance, so we need to get just our function down and get the minimum value of it by differentiating and letting it equal 0. 1125t squared, 1125t squared minus 2700t plus 8100 to the power of a half. So we need to differentiate this and let it equal 0 and solve. So s prime t is going to be a half by 1125t squared minus 2700t plus 8100 to the power of minus a half times the differentiated bracket. So 1125 twice, 2250, 2250 t minus 2700. So we could tidy this up. It's going to be equal to 0. So if it's going to be equal to 0, what can we say? So if we're to let all of this equal 0, this guy's going to drop down to the bottom. So the top of the fraction will have to be equal to 0. So it doesn't matter what we have on the bottom, which is 2 times the square root of this whole thing. So we can jump to the top of the fraction, which is going to be 2250t minus 2700 would have to be equal to 0. To save yourself a bit of time, you could say that is equal to that. So t is equal to 2700 or 270 over 2250. You can put your extra zeros in if you want, and this works out to be 1.2. And is that in hours? We're dealing with t in hours, I think. Yeah, hour. We're dealing in kilometers there. Hours. Hours, not seconds. And what are we asked? That's the value of t. Hence, give the distance in kilometers, correct to 1 decimal place. And now we need the distance. So be careful where you sub it back in. This is our distance. So we're going to get s of 1.2, which is 1125 by 1.2 to be squared. And this is all to the power of a half. So you can put your square root if you're using your calculator on at the beginning. Minus 2700. Or you can put it to the power of a half on at the end. 2700 by 1.2 plus 8100. And that's giving me s of 1.2 to be 80.5. That's kilometers.